This is the second video on electrolysis, and it covers some more complications related to the topic of electrolysis. And if you want to see the very basic concept, what is electrolysis, what are electrolytes, and the terminologies related to it, please kindly watch lesson number 1 on my YouTube channel. In this video, we are going to deal with the electrolysis of aqueous solutions of the compounds. They can be your dilute solutions or they can be your concentrated solutions. Now, the first case is where we are dealing with the electrolysis of dilute solutions, right? Now, whenever we have to deal with the electrolysis of dilute solutions or the concentrated solution, there are rival ions. Like, for example, if I talk about aqueous sodium chloride, when I talk about the aqueous sodium chloride, that means I have the sodium ions, I have the chloride ions, I have H positive ion, and I have OH negative ion. Previously, in lesson 1, where am I talking about the molten electrolytes, there we don't have the rival ions, but in this dilute or concentrated electrolytes, because apart from the electrolyte of the compound, we also have the water ions. So the water ions are H positive and OH negative. So they are also present apart from the ions which are the part of your electrolyte. So these are said to be the rival ions. So Na ions and H positive ions, these are rival ions. They're competing with each other to reach the electrode so that any one of them can be preferentially discharged. Similarly, the ions like chloride and OH ions, they both are negatively charged. They both are anions, and they are said to be rival anions. And they both will be moving toward the anode, and they want to be preferentially discharged. But the preferential discharge of the ions depend on their position in the electrochemical series. Now, this is an electrochemical series for a cation, and we have an electrochemical series for an anion. Now, the position of these rival ions on the electrochemical series, the cation's position on the cation electrochemical series, and the anion's position on the anion's electrochemical series will decide that which ion will be preferentially discharged, and hence which product will be formed. Now, the first example is the example of your sodium chloride. Now, when we have a case of sodium chloride, as I've already told you, there will be the rival ions. These are the ions which are the part of an electrolyte, sodium ions and chloride ions, and we have the ions which are coming from an water. That's H positive and OH. Now, out of these two ions, which are the rival ions, we'll check their position in the electrochemical series. And as this arrow says that whichever ion is present, which is lower down in the electrochemical series, will be discharged. So let's look at the position of Na ions and the position of the H positive ion, the electrochemical series. The position of the anion is much above the position of hydrogen ion. So as the arrow says that, the position, the one which is the lower down in the electrochemical series will be discharged. Ease of discharge is downward, because when you talk about the cations, the one at the bottom can easily accept electron, right? The reason is by it accepts the electron easily because on the top we have the ions of the more reactive metals. So more reactive metals, they will prefer to remain in their ion form. So they will have a difficulty in accepting the electron. Whereas when the least reactive metal is at the bottom, and they'll prefer to remain in the metal form. So that is why as you go down the series, they will prefer to accept the electron. So that means the hydrogen ion will be accepting the electrons easily, right? So according to its position, so hydrogen ion will be preferentially discharged. So hydrogen ion will be preferentially discharged, right? In comparison to the sodium ion. Similarly, we have the anions. So anions, in the anions again, the one at the bottom, the lower one will be discharged. So here we have the OH ion at the bottom of the series, the anion series, and the chloride is much above it, right? So the one which are at the bottom, they can lose electrons easily as compared to the ones lose electron easily comparatively to the one which are above, right? So over here, out of these two rival ions, hydroxide and chloride, the OH ion will be preferentially discharged easily. Now, once this has been decided that out of these two, which need to be discharged, both of these ions, both the rival ions will be moving toward the electrode. The both will be moving toward the electrode, but towards the electrode, but only one will be discharged. Out of they both will be moving toward both the cations will be moving toward the cathode, both the anions will be moving toward the anode, but only one will be preferentially discharged. So the one which is preferentially discharged in this case is hydrogen ion as a cation, and OH ion will be preferentially discharged as an anion. Once we know that which ions will be discharged at the anode and the ones which will be discharged at the cathode, we are in the position to write down the anodic and the cathodic equation. So first of all, we'll prefer to write down the anodic equation. That means the OH ion. What will happen? The OH ion will be discharged at the anode. So whenever the OH ion will be discharged at the anode, you will always get a product of 2H2O, and it will be losing 4 electrons. So basically the 4 hydroxide ions will be forming 2 water and the 4 electrons will be lost. And we know that the hydroxide ions are coming from an aqueous solution. So we'll write down the state symbol AQ here, and the water has its state symbol liquid. So this is going to be the anodic equation. So this anodic equation is actually losing 4 electrons. The amount of electrons lost at the anode will be gained at the cathode. Now at the cathode, what is being discharged, preferentially discharged? It's the H positive ion which has been preferentially discharged. The 4 electrons will be accepted by 4 H positive ion, 1 electron each by 4 H positive ion. And the product will be formed, that is hydrogen gas. So hydrogen will be existing in the form of gaseous state, whereas the hydrogen ion are coming from an aqueous electrolytic solution. So these are basically going to be my anodic and the cathodic equation. And these are also known as half equation. They're also known as half equation. And we always write down the half equation along with the state symbol, keeping in mind that we have to balance the amount of electrons there. So that is the reason we always write the anodic equations first, so that we know that how many electrons are being lost, followed by the same number of electron accepted at the cathode. So this is basically all the details mentioned on this slide, and this is the apparatus for the electrolysis of sodium chloride, which I've explained in the previous slide. Now, as I told you that the anode, we were getting at the anode, the OH were being discharged, and the 4 OH were giving us how many? Oxygen gas. Whereas the 4H positive at the cathode was giving me the 2 hydrogen gas. So they both are gases. So if we want to collect these gases, then we will be having this kind of a setup for an electrolytic cell. Now, what do we have? We have the 2 electrodes here. These are 2 inert electrodes, which I'm marking here. These are the electrodes made up of carbon. They are your inert electrodes. Now, over these electrodes, we have the inverted test tubes there, which are basically graduated, which are marked so that we can measure the gas collection there. And we have an electrolytic solution of sodium chloride there, right? So when the electrolysis starts, that at the anode, we will be getting 1 mole of oxygen gas, whereas at the cathode, we'll be getting 2 moles of hydrogen gas. So over here, this is the smaller line shows the negative terminal of the battery. The bigger line shows the positive terminal of the battery. So this is basically your positive electrode. So the positive electrode is the one at which the anion move. So basically we call it an anode. The negative terminal is the one at which the cation move, and this negative electrode, we call it a cathode. So as we already know that at the cathode, we are getting 2 moles of hydrogen, right? So we are getting 2 moles of hydrogen here, whereas at the anode, we are getting just 1 mole of oxygen there. We are just getting 1 mole of oxygen. So the molar ratio is basically 1 oxygen and hydrogen molar ratio is 1:2. So that we can see the gas collection also. The gas A, which is being collected at the anode, which is basically my oxygen gas. And the gas B is the cathode at which the hydrogen gas is being liberated. So oxygen and hydrogen, we are getting in the ratio 1:2. We are getting 1 volume of oxygen and we are getting 2 volume of hydrogen. And that can be seen with the space here. The empty space here is actually showing the amount, the water being pushed down. And as the water being pushed down, the gas is being collected in the inverted test tubes. So we are getting 1 mole of one volume of basically 1 mole of gases being collected in the ratio of 1:2 volume here as an oxygen and as hydrogen. So whenever we get to see 1:2, we in some of the MCQs they give you this kind of a ratio with the apparatus setup. Whenever you get to see this kind of a ratio, we know that we are being what is the two gases which are being collected are oxygen and hydrogen, and they are in the ratio of 1:2. Apart from this, they also ask you that these are the two gases. How will you identify which gases are these? So we know that the identification test for an oxygen gas is that when we bring a glowing splinter, the glowing splinter relights again. And if we bring a burning splinter, the burning splinter extinguishes, giving you a pop sound. That's an identification for the hydrogen gas. So the hydrogen and oxygen gases, they can be identified by performing these two tests. Whichever test is positive, we can confirm the presence of that particular gas. So this is how the slides show you the complete details, the happenings at the anode. The anions are OH and Cl ions, which are moving toward the anode. But out of these two ions, only one will be preferentially discharged, right? Whereas when you talk about the OH ions, they will be selectively discharged. They will be preferentially discharged according to the position in the electrochemical series. And now when the OH ion be discharged, so for OH ion, they will be forming 2 water and they'll be forming oxygen by losing 4 electron. Now, what will happen at the cathode? The hydrogen and sodium ion, they both will be moving toward the cathode, but only the H positive will be discharged, selectively discharged because of its position, because it's at the bottom, it's below sodium, so that it can easily accept the electron. Now, the gas which is being given because of the hydrogen is actually your hydrogen gas, right? So this is about the electrolysis of dilute sodium chloride. Similar is the case when we have dilute sulfuric acid. When you have a dilute sulfuric acid, then the ions which are present are going to be hydrogen ion and sulfate ion. And apart from the hydrogen and sulfate, we are going to have hydrogen and OH ions which are coming from water. Again, these two are the rival ions, but they are not rival because they are the same ions. But here we have the rival lines of the sulfate ion and OH. So they both are going to move towards the anode, but only one will be preferentially discharged. Here there is no rival ions, so the hydrogen ions, they will be moving towards the cathode, right? So when they'll be moving toward the cathode, so hydrogen ion will definitely produce the hydrogen gas. Out of these two ions, the one which is below, right? So one which is below will be discharged. So in the previous slides, we have seen the electrochemical series for an anion, and we know that the OH ions are below the sulfate ion. So that means the OH ion will be discharged. So whenever the OH ions are discharged, so 4 OH ions, basically, the 4 OH ions, they give you oxygen and they give you 2 water, right? So they basically produce the oxygen gas. They liberate oxygen gas. So at the anode, this is an anode. So which gas is being given? It's the oxygen gas will be given. And at the cathode, this is a cathode. So at the cathode, we will be getting hydrogen gas. Now, hydrogen gas, we are just getting hydrogen. We are getting 1 mole of hydrogen. And okay, here there's a mistake in the printing because the 4 electrons are being lost by 4 OH ions. So basically there will be 4 electrons will be accepted by the hydrogen ion. So basically the 4 H positive ions will be accepting 4 electrons. So that will make the 2 hydrogen molecules to be formed. So hydrogen and oxygen oxygen is being formed at the anode and hydrogen is being formed at the cathode. So these two gases are always formed in the ratio of 1:2. So that can be seen here. This is the ratio of 1:2. So whenever we get a ratio of 1:2, we can say that these are the hydrogen ion being discharged and the OH ion being discharged, and the product are oxygen and hydrogen, which are in the ratio of 1:2. So this is another case where the oxygen hydrogen will discharge. The previous case we have seen of dilute sodium chloride. This is the case 2 of dilute sulfuric acid. There also oxygen and hydrogen being discharged. Now, sometimes in the paper, they say that the electrolysis of acidified water, if we get to see somewhere written the electrolysis of acidified water. So acidified water also means that in water we have added some amount of sulfuric acid to it. So acidified water means the electrolysis of dilute sulfuric acid only. So don't get confused by looking at the acidified water. That also means the electrolysis of dilute sulfuric acid only. Here come the third example, which is a very important example. That's example of dilute copper sulfate solution, right? Now, when you talk about the dilute copper to sulfate solution, then the ions present in this solution will be your copper ions and they will be your sulfate ions coming from an electrolyte. Apart from that, you'll be getting H positive and OH negative coming from the water. So these two are your rival ions, the cations, and these two are the rival anions. They both will be moving, copper ions and the hydrogen ions, they'll be moving toward the cathode, but only one will be discharged. Similarly, sulfate and hydroxide, they both will be moving toward the anode, but only one will be discharged. And we already know that the discharge, the preferential or selective discharge, depends on the position in the electrochemical series. So out of these two ions, whichever is below. Now, when we write down the electrochemical series, we always write down, please send cat, monkeys, and zebras in tin lead hired cages. Make sure padlock good. So hired and then comes cages, right? So below hydrogen are the copper ions. So definitely the preferential discharge will be of copper ions. And here we already know that out of the sulfate and the OH ions, the OH is always below. So OH will be selectively discharged. So first of all, we prefer to write down the anodic equation. The anodic equation is at which the oxidation take place. Now, when you talk about the anodic equation, then at the anode, the OH ions have been discharged, and always we have the 4 OH ion. They will be losing 4 electrons to form 2 molecules of water and 1 molecule of oxygen. And we know with the half equation, we always need to write down the state symbols. So this is aqueous, this is in the liquid form, this is a gaseous state, right? Then these 4 electrons will be accepted at the cathode, right? So at the cathode, as I already told you, the copper ions are below hydrogen. So what will happen? This is your anodic equation. So at the cathodic equation, we will have the copper ions. They will be accepting whatever the number of electrons being lost at the anode. So 4 electron loss. So 2 copper ion will be accepting 4 electrons to form to copper, which will be deposited at the cathode. So we can see a layer deposits all around the cathode, the pink color deposit around the cathode. So this is going to be the observation here. Whereas at the anode, will have the oxygen being liberated, which we can test by bringing a glowing splinter, which will relight again. So examiner asks you in the ATP paper, the observations, what happens during the electrolysis of copper, dilute copper to sulfate. So these are the observation. Number one, that you will be seeing the reddish brown deposits, or you can say the pink deposit, reddish brown deposits. You will be seeing at deposits will be seen at the cathode, right? And apart from that, you will see what the bubbles are seen at the anode, and these bubbles are of oxygen. So whenever a gas is being liberated, we always have to give the ionification test. When we bring a glowing splinter here, so glowing splinter is going to relit, and this is going to confirm the presence of oxygen gas. Now comes the third observation. Because the copper ions are being deposited at the cathode, the copper ions are being deposited, so the copper ions concentration is being reduced in an electrolytic solution. Now, because the copper ion solution ions concentration is reducing in electrolyte, and the color of the electrolyte is blue because of the copper ions, right? So electrolyte is blue, electrolyte color is blue because of the copper ions which are present. So as the copper is being deposited on the cathode, right? So what will happen? The blue color start fading off. The blue color of the electrolyte, fades off, right? Because as the copper ions being deposited at the cathode, will start fading off. So these are basically three important observations which we'll be seeing while the electrolysis of copper sulfate take place. So always remember, if we have a copper electrolyte, it can be copper 2 chloride or copper sulfate or copper nitrate, or right. So remember, always whenever we have hydrogen and copper ions, the one at the position niche hoti hai, right, that is going to be discharged. So copper is always below the hydrogen. So whenever we have a copper electrolyte, it's the copper which will always discharge, right?